Bismillahirrahmanirrahim. Dear students, we are continuing with the alkenes, grade 12. This is the lecture number 33. So, we are talking about the nomenclature of alkenes. So, there are different names and structures, just like I am giving you one example. CH2 double bond, CH, then CH double bond, then CH2 like this one. So if you have like this structure and it contains two double bonds, I told you that when you are going to give the name of the alkenes, select the longest carbon chain which must contain double covalent bond, but this contains two double bonds. The rule is same that you have to start numbering from that side where the double bond is near. 1, 2, 3. 1, 2. So nearest from here. So this is 1, 2, 3, 4 and 5. Positions 1, 3, carbon 5. Two double bonds, pentadiene. 1,3-pentadiene is the name of this organic compound. And now, if like this, which is given in your book, CH2 double bond, C2H5, CH double bond, CH2. So students, you are seeing that here at one carbon there is a double covalent bond. See this one. And there is a branch, two carbons are here. Starting from here and very first carbon atom, there is a double bond again. So first carbon 1, 2 and 3, there is a branch. Starting from here 1. On very first carbon there is 1 and there is one carbon. And there is one thing. If we write in this form, suppose I am going to start from here 1, 2, 3, 4, 5 longest tail, and 1, 2, 3, 4 longest tail, 1, 2, 3, 4 longest tail. But if you start from here 1, 2, 3, 4, 5, this double bond is left. The very important rule for alkene and alkyne is you have to select the longest carbon chain which must contain double covalent bond. If there are two, must they contain the chain. That's why this will not include in the longest chain. That's why 1, 2, 3 and 4, because this branch is nearer. 2 carbon. So 2 ethyl, 1, 3 butadiene. 1, 3 butadiene. This is given in your book. There is one thing. If triple bond in this compound, triple bond and double bond are present. There the triple bond and there the double bond. So, starting from here, 1, position number 1, there the triple bond. Starting from here, 1, there the double bond. So, the question is, from which side you start the numbering? If position of double bond and triple bond is similar on either sides, then according to the reactivity, double bond is the most reactive. Reactivity, I am telling you, double bond is most reactive, then triple bond, then arene, benzene, then alkane. So double bond is most reactive. That is why 1, 2, 3, 4. 1, 2, 3, 4. This is the numbering. Start from here, triple bond, but triple bonds must not reactive as much as the double bond. So must start from here, 1, 2, 3 and 4. Then alphabetically, 1, ene, 3, vyne, 1 ene double bond, 3 vyne triple bond, 4 butane. 1 ene, 3 vyne alphabetically, E and Y. 1 ene, 3 vyne butane. Same case, if like this, in this case, if you start from this side, 1 carbon has a triple covalent bond. First, here 1 and 2 there is a double bond. Now, see the position, because here was the case that the position of the triple bond and double bond is a similar, same. Starting from this side and from this side. That's why we prefer the double bond due to its reactivity. But here in this case, triple bond is the carbon number 1 and double bond is carbon number 2. So triple bond is near 1, 2, 3, 4, 5. Like this one. So that's why the name of this compound will be 1, 2, 3. 3 in 1. 1 vyne pentane. And in this case, there is another common name you must remember. The rule I am telling you. Look here, students. If there are 2 carbon atoms containing double covalent bond, if there is a functional group attached, this is also functional group. Like this one. So this is a functional group. me carefully. If the two carbon atoms, double covalent bond is there, with the carbon any functional group is attached, then this two carbon containing double bond is called vinyl. We call vinyl this. So name from here to here, here to here, and also here to here is vinyl chlorine, vinyl chloride, vinyl chloride, vinyl alcohol, vinyl acetylene, vinyl alcohol, vinyl acetylene, vinyl chloride. So this is a vinyl, don't forget. Like the same, this is a vinyl, this and acetylene. So second name of this compound is vinyl acetylene. Vinyl acetylene. So these are the names for the alkenes and alkynes. Now I'm going to give a few examples when you have a name containing double bond or triple bond or both, how we draw the structure. This is the structure and we give the names. Now names, we have to draw the structure. Just like see the question, activity question here. Two methyl 1 3 butadiene. And other 3 methyl 1 3 pentadiene. Now if this one longest chain contains 4 carbon atoms. This is the rule. If you are drawing the structure of the organic compound, alkenes, alkynes, C is number 1 step. How many number of carbon atoms are there? 4. But give numbers. Okay. After the numbers, see the position of double bond. 1. This is carbon number 1. 3. This is carbon number 3. This is 2. Like this. 2 methyl. This 2 methyl. 1 double bond. 3 double bond. So 1 3 pentadiene. Reason because starting from here, double bond is also carbon number 1. Starting from here, and the position of double bond is also carbon number 1. But here, this branch methyl group attached with this carbon, so double bond and this branch prefer to start numbering from the left side. Okay, this is the pair. Now about this one. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5 like this. So 1 and 3 and position 3. So starting from this side, 1, 2 double bond. 1, 2 double bond, and there is a methyl on the carbon number 2. If we start from this side, here on very first carbon there is double bond, so we prefer it. The position of double bond is preferred because this is at carbon number 1. So let's have a see. Like this one. 3 methyl, 1, 3 pentadiene. So dear students, this is the nomenclature of alkenes and alkynes. You have to solve all the questions from here, also from the your question papers, previous question papers of Federal Board or other. Nomenclature is same, chemistry is same. You have to solve. They will help you. Now the other topic is relative stability. Relative stability. There are 3 factors which influence the relative stability of alkenes. 3. There are 3 factors which influence the relative stability of alkenes. Number 1. Degree of substitutions. Degree of substitutions. Degree of substitutions, number 1. More highly alkylated alkenes are more stable. So the stability of alkenes decreases. Tetra, tri, di, mono. This is the stability of alkenes. Highly alkylated alkene is the most reactive. Just like is the highly alkylated. 1, 2, 3, 4 branches. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 7. So 2, 2, 5, 5. Tetra, methyl, 3, hexene. This is the most alkylated. Tetra, 1, 2, 3, 4, tri, di, and mono. This is number 1. Stereochemistry. We will do here. Trans alkenes are more stable than cis. This is a type of the isomerism. We will discuss in detail. And this type of isomerism is called geometrical isomerism or cis and trans isomerism, where the structural formula of the organic compound is same, but the position of the alkyl groups or maybe halogen groups in the same compound is different. So this is called geometrical isomerism or cis and trans isomerism. So I am giving you an example of cis and trans. Just like this is the alkene and there is a methyl group and hydrogen and hydrogen. Same alkene, this is the methyl group, hydrogen and like this. So, students, see this one. This alkene is named 1, 2, 3, 4. Cis 2 butene. 1, 2, 3, 4. Trans 2 butene. Both 2 butene. If the same groups are on the same side, upper side, this side, same group are present on same side, 2 hydrogen present on same side. If 2 groups are present on same side, maybe they are hydrogen, maybe other group, maybe alkyl, same side, to this stereochemistry give the name of this structure, geometric isomerism give the name cis. This type is called cis. The name of this compound is cis 2 butene. And if you see this one, they are opposite. See this? Opposite. Same side different. So if these alkyl groups are opposite, this arrangement is called trans 2 butene. So here in the stereochemistry, the example is given: trans alkenes are more stable than cis. Why? Because due to the reduced steric interactions when alkyl group are on opposite side of the double covalent bond. This is more stable than this. Trans opposite side reduce steric interactions when alkyl groups are attached on the opposite side of the double bond, opposite side of the double bond, same side of the double bond. So due to this reason, transalkanes are more stable than alkenes. Transalkenes are more stable than cis. Number 3. Conjugated alkenes are more stable than isolated alkenes. Number 3 point is that conjugated alkenes are more stable than isolated alkene. First, you have to see that what is the conjugation and what is the isolation. Isolated. If you see the structure of the benzene, there are 3 alternate double bonds present inside the ring. Alternate. In this structure also you will find on carbon number 1 there is double bond, 2 vacant, and third there is double bond, there is alternate. So this alternate position of double bond present in alkene or benzene or alkyne, this is called conjugation. Isolated, you will see more gap. 1 carbon, double bond, no double bond, no double bond, carbon number 4, there is double bond. So there is more gap or there is 1 bond. This is also isolation. This also. Sorry, sir. This is also isolated. So you are finding more gap on carbon number 2, no, carbon number 3, no, carbon number 4 there. So 2, but here is the 1 gap only. So this is the isolated and this is the conjugated. The name of this compound is the 1 and also 3,1,3-butadiene, and here is the 1,4-pentadiene. This is the isolated and this is the conjugated, and shows more stability because 2 bonds are alternate positions. 1,3-butadiene, 1,3-butadiene, the same I have written here. And in your book, the other name is wrong. That is a 1,4-pentadiene. This, write this one, 1,4-pentadiene. The example is wrong given in your book. 1,3-butadiene, 1,4-pentadiene. So this conjugated is more stable than that of the So these are the three factors. Now structure. Of alkenes. In alkenes there is a double covalent bond, sp2 hybridization. If you revise chapter number 3 for the bonding in the grade 11, carbon links with pi bonds, sigma bond and pi bond. You are seeing here structure, sp2 hybridization overlapping between the 2pz and 2pz to give a pi bond in presence of sigma bond, sp2 hybridization, and this carbon-carbon distance is shorter, 1.34 angstrom. Instead of carbon-carbon single bond distance is 1.54 angstrom. So all the hybridization also affect the distance we call bond length, internuclear distance, bond length between the carbon-carbon atom. So double bond, one sigma bond is there and one pi bond is there. So they are the influence of the overlapping of the unhybridized atomic orbitals. So that's why 1.34 angstrom in the case of double bond and 1.54 in the case of double bond. So there is a high electron density between the carbon-carbon atom and the double covalent bond. So due to this reason, double bond is more reactive than single bond. So these carbon-carbon are coplanar, and the reaction of one carbon with respect to other restricted with result cis-trans isomerism. So cis-trans isomerism is due to the presence of double covalent bond. Restriction. Cis-trans isomerism in alkene is restricted due to the restriction. A special kind of geometric isomerism will be formed that is called a cis-trans isomerism. So dear students, we are going to finish here, and we are going to continue this chapter, this very long chapter, and inshallah in the next lecture we will discuss about the preparation of alkenes. Preparation of alkenes we will discuss. Thank you.